Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, my friend Sarah and I will be presenting about our topic, which is cryptography and blockchain. So our main topic today is about cryptography and blockchain. So we will be presenting about introduction of blockchains, how it works, and cryptography in blockchains, strengths and weakness of blockchains, and how blockchains can be applied in daily life. And lastly is the conclusion. So let's start with the introduction about blockchain. So what is blockchain? So as the name suggests, blockchain, block and chain. Blockchain is a set of blocks that are connected together and chained together. So that's hence the name is called blockchain. And what is on those blocks? So each block will contain details and information, and also in the block, the blocks are connected by a pointer of the previous block in the chain. So a block will contain hash pointer that will be pointed to the previous block. So history about blockchain. It all started in 1976, where a paper regarding new directions in cryptography was published. And then later, in 1997, there was a concept brought by Adam Beck about hash cache concept. So what is hash cache? Hash cache concept is introduced to combat and organize spam emails. And this concept later led to B-money, which is the creation of digital money. Next, in 2008, the first paper on Bitcoin was published by Satoshi Nakamoto. And later next year, in 2009, the first Bitcoin was created. Then I will pass to my friend Sarah for how blockchain works. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. So thank you, Rifki. So I'm Sarah. I will present about how the blockchain works. So basically, blockchain consists of three main things, which are the data, the hash of the block, and the hash of the previous block. So accepted transactions are structured into secure blocks of information connected in virtual chains. So there are 8 key attributes of blockchain, which are transparency, trust, immutability, pseudonymity, verifiability, controllability, security, and also disintermediation. A blockchain might be either the transfer of a digital asset, for example, cryptocurrency token, or it is a tool to link information to a specific profile, such as for combining a university degree with a digital identity. So the transaction logged on the blockchain is irreversible and also unchangeable. So the transaction, the input will be an array of previous transaction, and the output will be an array of recipient addresses. So it can be seen through the diagram shown in the slide. So we will continue with Brother Rifki. Thank you.
All right. So thank you, Sarah. Next, we will proceed into the next subtopic, which is cryptography in blockchain. So in blockchains, there are multiple cryptographies implementation used, but in this slide, I will cover the two most common cryptographic algorithm, which are hash function and asymmetric algorithm. So in cryptography, hash function is widely used. What is hash function? Hash function is strings generated in bit sequence form. So let's say we have a plain text, and which we when we insert into hash function, it will generate uh, a, a totally different string and in fixed length. So uh, the characteristic of hash function is the security features of hash is pre-image resistant, second pre-image resistant, and collision resistant. So uh, hash function also uh, sensitive to change, which if the plain text has changed even one bit, a totally new hash string will be generated. So it can be said that hash functions, the security of hash function is it the attackers cannot tamper with the contents of the blockchain. So hash function is used to map the blocks to the respective previous block. So in the picture below there, in the second block, they have the hash of block of the previous block. So that's how the blocks are connected to each other and then forming blockchains. So second cryptography algorithm in blockchains is a symmetric algorithm, or also known as digital signature. So asymmetric means not equal. So it consists of two type of keys, which are public keys and private key. So how it works? The sender will have a plain text that will, and the sender will encrypt using uh, private key, and then the receiver will be able to decrypt using his private key. So this asymmetric algorithms, digital signature can be used to verify the authenticity of the message. Because if the message are not from the expected sender, so the receiver cannot decrypt the message, and the the decrypted message will not be the same as the sender. So it uh, it will provide security and authenticity in blockchains. So that's a brief uh, about cryptography in blockchain. So I will pass to Sarah again for the strengths and weakness in blockchain. Thank you.
Thank you, Rifki. So next, I will be presenting about strength and weaknesses of blockchain. So there must be challenges and problems, even though the blockchain is secure and in high insecurity, it still have lackness or weaknesses. So the challenges and problems that the users might face are three challenges which are scalability, privacy leakage, and also selfish mining. So for scalability, the huge amount of transaction that occur in the blockchain will definitely need a huge data storage. So the might be the size of the storage. For the privacy leakage, there is a possibility that the value of all transactions and balances for each public key are publicly visible. So proceed to the selfish mining. The network is vulnerable even if only a small portion of hashing power is used to manipulate. However, there is some solution that can be taken to improve the blockchain itself. So the solutions is storage optimization of blockchain. There is also we can do is redesigning the blockchain. So both solution is for the scalability problems. Then we proceed to mixing. Mixing will provide anonymity by transferring funds from multiple input addresses to multiple output addresses. And anonymous, miners only have to validate the coins belonging to a list of valid coins, but do not have to validate a transaction with digital signature. So mixing and anonymous is suitable to improve the problems which is a privacy leakage, because it secure the privacy of the users. So next we continue with Brother Key again. Thank you.
Okay, thank you again, Sarah, for the presentation. And next we will proceed with the application of blockchain in real life. So with blockchain has a lot to offer. Industries and many individuals have been taking advantage of this blockchain. So in this slide, I will be touching about three applications, which are decentralized storage, decentralized IoT, and public ledger. So for decentralized storage, it's like cloud cloud storage, but users can share and store their documents and files without the need of having third party by using P2P or peer-to-peer cloud storage platform. So the file are stored in multiple nodes, and then the file will be shared with using peer-to-peer. It means it consists of many users, and all the users will be sharing the files together. So one of the uh, decentralized storage out there is storage. So next, for the second application is decentralized Internet of Things, or IoT. So IoT is Internet of Things is the application of internet to control all the devices using internet. So decentralized IoT is blockchains is used to store and establish secure communication between IoT devices. So the IoT devices will be connected to each other through blockchain, and this concept has been developed by IBM in collaboration with Samsung. Uh, they came up with a concept called ADEPT. So that's for decentralized IoT. And the third application of blockchain is public ledger. So for public ledger, so the properties like houses, car, and anything, and transaction details are being stored in public ledger. That means um, the ledger can be verified and can be observed to be checked by authorized personnel. So just like normal ledger, but with cryptography, with blockchain, the ledger cannot be tampered because of the security and authenticity that blockchain has to offer. So the ledger is secure and authentic, and that's the three of the application of blockchains in real life. Thank you.
So we have reached at the end of the presentation. So in conclusion, the blockchain and cryptography are linked with each other. Blockchain and cryptography give protection and privacy to the transaction activities. Both of them also have a potential to grow in their industry, especially fields that are related to finance and Internet of Things technology. So the implementations of blockchain and cryptography should be explored more and could be enhanced to make sure that the security measures are something that cannot be compromised. So that's all for our presentation. Thank you. Assalamualaikum.